What would happen to the sample if we steadily increase the temperature at constant pressure? That is, move horizontally from left to right on the diagram. The changes depend somewhat on the starting pressure. Let's begin at some pressure between the critical point and the triple point. Starting with the solid, we increase the temperature until the solid and liquid are in equilibrium. Increase the temperature above the melting point and pure liquid exists. Then, the liquid and gas are in equilibrium, and further heating vaporizes the sample to the gas. Suppose we had begun at some pressure below the triple point pressure. We begin with the solid as before, but heating brings the solid into equilibrium with the gas, not with the liquid. And further heating sublimes the solid to the gas. Carbon dioxide behaves this way. It has a triple point pressure of 5.1 atmospheres. Warming a piece of dry ice at ordinary room pressures of around 1 atmosphere changes it directly into the gas. Liquid CO2 is not stable at 1 atmosphere. Now, let's see the changes the sample undergoes as we decrease the pressure at constant temperature. That is, move down the phase diagram. Here, the starting temperature determines how the sample changes. If we start with the solid at some temperature higher than the triple point temperature and lower the pressure, we first reach the solid-liquid equilibrium state. Thus, the sample melts due only to a change in pressure. Then, the pure liquid exists until a further pressure decrease balances liquid and gas in equilibrium. And finally, the pure gas. Notice that if we start at any temperature lower than, to the left of, the triple point temperature, we move directly from solid to gas. Here's the phase diagram showing all the regions, points, and equilibrium processes.
By referring to the phase diagram of water, describe any changes in the phase present when water is kept at 0 degrees Celsius while the pressure increases at point 1 to that point 5, the vertical line. Note that the vertical line, the pressure will be increased, but the temperature is the same, which is 0 degrees Celsius given to us. At the same temperature means isothermal. We have to explain the phase changes from point 1 until point 5 given. Point 1, we can see that water will exist totally as a vapor. Point 2, the point is at solid-gas equilibrium line. So, a solid-vapor equilibrium exists. Point 3, you can see that it at solid area. So, all the water is converted to solid. Point 4, it's between solid-liquid equilibrium line. So, equilibrium between solid and liquid is achieved. Point 5, it's at liquid area. As the pressure increases, all the water melts, so only the liquid phase is present. By referring to the phase diagram of water, describe any changes in the phase present when water is kept at 1 atm while the temperature is increased from that at point 6 to that point 9 horizontal line. Note that when we keep the pressure at 1 atm while the temperature is increased, the term is isobaric. Look at the point 6 until 9. We need to explain the phase changes occur. For point 6, it is solid area, means that water will exist entirely as solid. Point 4, when the temperature reaches point 4, the solid begins to melt and the equilibrium exists between the solid and liquid phases. Point 7, we can see that the point is at liquid area. At even higher temperature, the solid have been converted entirely to a liquid. Point 8, it is at liquid-gas equilibrium line. A liquid-vapor equilibrium exists. And point 9, which is at the gas area, upon further heating to point 9, water is converted entirely to the vapor phase.